Okay, in this YouTube video, we are discussing about system design for e-commerce application. System designing is one of the practices for the software development. Before building any application, designing the architecture, designing the system is very important. Uh, so, experienced the software developer, the people who are having experience in IT and software development for many years, they'll have the knowledge of designing the architectures before even they are developing an application. So they will design the high level architecture and they will come up with the components required for building an application, and also they will foresee any risks are there for building when they are building applications, and how to mitigate those risks. So they will have all these things in their mind, and they'll put them in a document. The thing is, when you are designing system, you need to understand the client requirement, and you need to come up with the best feasible solution for building an application. The application should be effective with respect to the performance wise, and you should meet the demand of the user requirement. And also the designers should think in the future perspective, so that he could build an architecture that would be scalable in future, that can be upgradable to the new tech stack, and the system would be flexible to migrate to any new tech stack. And also the system should be scalable and reliable. These are the common factors, we know that. But the main thing is, when you are building in a system, you need to understand the functional requirements. You can see non-functional requirement, both are very important. Okay, functional requirements, you can see here what is the business use case. Okay, we need to build modules, we need to come up with the modules, or we need to come up with the components required for building an application as for the functional requirement. For example, you take e-commerce applications, so we need to manage the products and we need to manage the inventory. So this is one module, right? So number of products, managing the product catalog and managing the inventory is one of the functionality. And also managing the orders, processing payment, and managing the fulfillment, shipment details, notification details. Managing customer information, it is also one of the so you need to split the requirement into different functionalities, different modules. Okay, that way you can actually build required module components, or you can come up with the best architecture, whether you can go with monolithic architecture style, or whether you can go with microservice based architecture. Depends on the functional requirement of the business use case. So functional requirements are you need to understand the core business, what are the core operations of the business when you are building an application. Functional understanding the functional requirements is the key role, because 70% of application development depends on it. It is very important. So functional requirements are very important. So you need to understand them, because you are going to build the application for core business operations. Okay. And other thing is non-functional requirements. Non-functional requirement, you can see how available the system is. Okay, is the system scalable to support larger traffic? Okay, how secure is the system? These are non-functional requirements. Okay, so when designing the architecture, we need to keep in mind that we also come up with the plan for the non-functional requirements. Okay, and extended requirement is the third scenario. You can extend this for analytics, insights, for business purpose. You see, analytics are required for future purpose. As your business is growing, right, you need to understand the data and the past historical information to grow your business. So these analytics and AI integration, these are the new trends you can integrate, but main thing is the functional requirement, non-functional. Many companies, they may prefer this analytics and they may not prefer it, and AI integration is also not required, right? Some of the companies, why do they prefer AI integration except for chatbots? And most of the customer, they don't prefer to use a chatbot, they prefer to use a customer interaction. For banks, if it is a banks and financial institutes, right, they don't prefer to use it. If it is e-commerce applications, okay, that's fine. They still don't use, because they go for the searching option and they'll do the online searching, online. They want to experience the products, what are the products are there, So if any technical issues are there, immediately they'll contact the customer care. In very rare cases, they'll go for AI chatbot or anything. Okay, so that is the important thing. So you can use AI for personalization of showing different offer products recommendations. You can use that for advertising, sales purpose. For sales purpose, you can use AI. So functional requirement, understanding the functional requirement, understanding non-functional requirement is a key thing when you are designing a system architecture. Okay, system design, you want to design that system, and you want to design a system which is more reliable, scalable, secure. Okay, you need to keep these factors, and these factors are very important when you are designing system. And you need to understand the capacity of your system that you are going to build. Capacity estimation is a very important factor for designers. You need to understand how many what is the core business functionality, how many users are going to use your particular business, so how much load will come, how much traffic will come for your particular application. Based on that, you need to estimate the storage capacity required for storing customer information or orders information. You can see here, for example, 20 million daily active customers are there. Okay, out of 20 million, only 50% of the people, they actually purchase products from your website. Then 10 millions per day, right? And if at least 1 KB data is generated for one sale, for 10 million it would be 10 GB per day. So that way you need to calculate that for 1 million products. See, at least 1 MB metadata is required to showcase any product information. It will be 1 terabyte, right? So that way you need to understand per day how much storage will be occupied for the transactions. For particular, you see, for every second you may get 250 requests. So you need to understand the request per second. You need to understand the storage required for a day. You need to understand per year how much storage it will occupy. You also need to understand the bandwidth. Okay, for processing a particular request, sometimes it may take 100 MB per second. 100 MB of internet may require, or 125 MB of internet may require. So these are called capacity estimation. You need to estimate, you need to forecast, predict the it's not predict, you need to understand, and based on the forecast details for your business requirement, you need to design your storage, you need to design your network, you need to design your application. Okay, that is the main thing. And you can see here, capacity estimation part of capacity estimation is a part of application. And you can see design approaches. What are the design approaches? So what kind of architecture you want to adapt here? Are you going to adapt a monolithic architecture? Are you going to adapt for microservice based architecture? Okay, there is an architecture, serverless architecture. Nowadays most of the companies are going for serverless. They are migrating to the cloud. But the many e-commerce applications, they still rely on the microservice based architecture. Here they follow the domain driven design. You can see DDD, using DDD, domain driven design, identify the modules and services considering for business domain and context boundary. As I told you, right, if you take e-commerce application, you can see the users will be there. Who are the actors here? Users. And product catalog service. There will be product catalog, there will be inventory service, order service, fulfillment service, notification service, fulfillment or shipping service, right? Notification service, analytics and AI services for recommendations or personalization purpose. Okay, so as I told you again, functional requirement, understanding the functional requirement, understanding the non-functional requirement, understanding the capacity of a system, and you need to come up with the required storage servers, required CPU processing and network capacity, right? You need to come up with the basic details when you are building an application. Okay, capacity estimation will go parallel. You will discuss with the admin teams, storage deploy, server admin teams, and you need a servers. When you are going to build an application, you need to come up with the processing servers. How much CPU is required? How much storage is required? What kind of storage is required? Okay, I will discuss that. You can see domain driven model here. For each functionality, for each context boundary, you will create a separate microservice. Okay, and now you see what is a product catalog. Product catalog is a flexible schema required considering variable product attributes. You need to store the product details for product catalog. So you can use relational database or non-relational databases. Here for example, you are taking a document database like Elasticsearch, can be used for storing metadata with flexible schema. You can also use NoSQL databases. You can see Cassandra is there, okay, or MongoDB is there. You can choose any database here. Okay, that is the important thing. So let me explain you something here. When do you choose relational database and when do you choose non-relational database or NoSQL? If you want to, if your application requires most of the ACID properties to be fulfilled, what is ACID property? Atomicity, consistency, okay, isolation, duration, okay, and you see RDBMS databases are very important for ACID properties. So most of the banking applications, they prefer to use RDBMS because the core banking operations are more relate to the asset properties, right? Atomicity, right? Whenever some transaction should happen at any cost. If any transaction began, and it should be completed, it should not end in the middle, right? If it ends in the middle, then there will be a huge loss for a customer, right? For example, if customer wants to transfer a fund from one account to another account, if the transaction failed in the middle of processing, what happens? So it is a loss of money, though. So the thing is, either transaction should be completed all, or it should not be completed at all. So it is a kind of atomicity, consistency. So whenever you read a data, it should be consistent, right? It should be very consistent. It should not change that. It should not change that. Let's say if the user is having a balance of 1,000 rupees and he is reading the 1,000 rupees from mobile application, and if he reads the same account from some laptop website, he should see the same amount. He should not see the different amount. Or if he is accessing a next day, third day, the same amount should be there. Consistency is very important, right? And see, durability and isolation. I think one transaction should not depend on another. Let me clearly explain what is it. Asset properties. Let me clearly. Atomicity, consistency, isolation, durability. Okay, so isolation is independent. You see, when multiple transactions occur concurrently, they do not interfere with one another, right? As I told you, when you are withdrawing it, let's say two people are trying to perform with withdrawal option. So they should be isolated transactions, right? One transaction should not be interrelated with another transaction. If it happens, right, it will lead to the ambiguity and confusion. Let's say a user is trying to withdraw amount, another user is also trying to withdraw some other amount, and it would be a problem. So durability is a performance. So I forgot this. So durability is a performance. You see, once the transaction is committed, its changes are permanent. So whenever you deposited some amount, or you withdrawn some amount, once the changes are made or committed, saved, they are all permanent. They are not temporary. So that is called durability. So acid properties are very important, right, when you are designing a system. So that is why if your application is relying more on acid properties, you need to go for a relational database. Getting my point, right? You can use any RDBMS. There are so many RDBMS: Oracle, DB2, MySQL, PostgreSQL, okay, Sybase. So many databases are there, okay, and you can come up with a data model based on your schema. And also remember, when you are designing a database model, if you are using RDBMS and you are keeping the asset properties in mind for data schema, so you need to normalize the database, and you have to create the structured database. You need to create a proper tables, establishing foreign key relationship between multiple between tables, unique key constraints. You need to establish a unique key constraints if any constraints are there. So database normalization or schema normalization is very important. Okay, when you are designing a data model for particular RDBMS based database. Okay, so the data model is very important. So when you go for NoSQL, I'll tell you. So acid properties is not important for your business, right? No, following acid properties is not very important. You just want to store a data and you want to retrieve a data as fast as you can do. Okay, you want to store a data as an object. You want to get a data as an object. That's it. You take Twitter or Facebook or any other stuff. We will have the data in unstructured model, right? So we'll have different types of data objects will be there. The data is not structured, it is unstructured. We'll have the comments whenever the user is posting some information. We'll have body, some comments, information. We'll have subject details. So we want to store all this data of a particular JSON object into DB. Okay, there is no specific table for it because the number of attributes may increase or decrease dynamically, right? Some people may choose different properties to so the thing is, the data will be unstructured, it is not structured data. Okay, it is unstructured data. So and as per the business does not need to follow any ACID properties, ACID transactions. Then you go for NoSQL. For example, you take a MongoDB. MongoDB, when do you use MongoDB? For storing the logs. Applications servers, they always produce lots of logs every day. Okay, and these logs, they do not have a proper structure, and they are unstructured data. So we store the logging information into MongoDB and we'll get the data. If it is a Cassandra, it is a key value based, column oriented database, key and column oriented database. So every NoSQL database will have its separate data model. For MongoDB, it is a document based architecture. Cassandra is a key value, and graph databases are there, and some other databases also there. For Elastic Search Engine, you see, so many NoSQL databases are there. Some of the NoSQL databases completely file-based NoSQL databases are also there. Okay. So you need to understand this. Okay. So and also other thing is, when we are designing an architecture, you see, when do I use NoSQL? When do I use SQL data? We already discussed. If your business core operations are rely more on ACID properties, you go for relational database. Your requirement is just store data, unstructured data as an object into DB, and getting that as faster as you can do. If it is your requirement, then you go for NoSQL database. Okay, sometimes some people, they prefer to use both SQL and NoSQL databases as a hybrid architecture. Nowadays, most of the companies, they are doing it. You see, if you are using banking operations, what you do, you will actually use the SQL data, Oracle database, for storing customer information, transaction, and other data, and for storing some customer feedback, for getting the customer feedback or some other logs information. You can go for NoSQL like MongoDB, other stuff. Sometimes what you will do for creating a personalization or alert kind of system, you want to use NoSQL database for analytical purpose. You want to dump some historical data into NoSQL, and from there you can apply analytics, right? So that's where you will go for NoSQL database. So you'll use both SQL and NoSQL database for your application. Okay, that is the important thing. And also when you are designing a system, remember you can design architecture using synchronous based approach or asynchronous based approach. Asynchronous is nothing but event driven approach. Event driven approach, you use some messaging softwares like Kafka, RabbitMQ, or any messaging softwares for publishing data into queue, and other side consumers will consume the data and they write the data either to database, or they'll actually generate notification details using the data. Okay, these are very important things. And you see here, let me explain you this simple design architecture. I have seen it. You can see here the first request comes to the API gateway. From API gateway, it will go for any of the services. It may go for user service, catalog service, order service. Okay, it will go there. And you can see for order service, we are actually publishing some message after order is created, and we want to notify that. For that we need a notification detail. So we have a Kafka, right, and we are publishing some message, and based on that event, fulfillment service will be there, shipping service. It will consume that information of that particular event, and then it will do the shipping. And if notification service also use the same event for notifying that. And the other thing is, you can see some data aggregation related features we can apply here, like Flink. You can actually process data. You can apply some transformations on data, and you can dump that data into data lake, and from there this analytic service, AI service, they both use the data and they'll run it. Okay, it is a simple architecture, you can see. And other side, you can see we are using this AWS CloudFront, okay, for storing. What it will do, it is for storing a static content, CDN, content delivery network. You're using Cloud One, so in this diagram, and it will use the meta service, and metadata for particular files. It will be stored in the AWS S3 media files as per this diagram. Okay, this is a simple diagram. I don't want to discuss much about it. And you can see some of the AI analytical services. I'm going to ignore them because they are not very important right now. Okay, let's jump into here. So the thing is features. You can see features. What we are doing, we are creating API to manage the registration, customer details, product catalog details, order and sales details, and we need a cache. So when you are designing a system, caching the data is very important. So we are already using content delivery network for storing static files, and we can also use a Redis database for storing most frequently accessed data. So what kind of data need to be stored in cache? So here cache is, it is a kind of data storing layer between your application and a database. So whenever particular request is coming from the user, every request may not go to the actual database to retrieve it. So first time the request may go to the database, and it will get the data, and it will store the data in the cache. Okay, it can be Redis database, or it can be Edge cache. If you configure the third party cache, you can use it, right? So the thing is here, caching data is a very important, but what kind of data you will catch it there? So this is a e-commerce application. So generally, what is most frequently data, what is sensitive data, what is not non-sensitive data, you need to understand that. So you will not store all the data, all kinds of data in the cache, because the data is a dynamic sometimes, right? So every time the customer may not purchase the same products items, it will differ, right? So you will not store those details in cache. Getting my point? Only you will store the constant details and most non-sensitive information, right? Non-sensitive information. For example, you take a customer details, customer name, age and location details. You can actually store them in cache if you want to. So they are not very not sensitive details. They are not very confidential. But if you take customer card details, payment related details, okay, if you are some kind of sensitive information, you may not store them in a cache. They should be stored in database. We'll have a security data at encryption, okay. Data in transit, data at rest, in both the times we'll use the security encryption. So only the frequently accessed data, and that should be constant. Constant means that will not change very frequently. That is more of a static, and that should be non-sensitive data. Okay, store that in a cache. And security, you can actually use JWT token along with OAuth framework. Nowadays we are using it, right? And role based access, you can actually provide access. You can create roles, and based on the roles you can authenticate. You can authorize the particular user to access particular resource. And exception handling, so if you are building any application, you need to make sure the application should build properly. Whenever some exception is thrown at any component level, any layer, if you are not catching that exception, you may not be able to troubleshoot the application after deployment into the production. Now when you deploy your application into the production, okay, you need to monitor and maintain the application, right? You need to make sure the application is stable every time, otherwise it would be a problem, right? Suppose if some exception occurred, some issue occurred, and if you not handle the exception handling inside your application, you will not be able to capture the logs. You will not be able to understand where the particular exception is coming. It would be very difficult. So exception handling would be very useful. So you want to catch the particular exception, and you can actually feed those information into the logs, and based on those exceptions we will be able to troubleshoot the application, and we can actually fix those issues. And Swagger docking, Swagger feature, API sandbox. So Swagger, it is optional. You can actually either use it or you may not use it. But most of the time they prefer to use API testing tools like Postman tool or some other tools. In production they don't prefer to use Swagger, they disable it. Swagger would be useful, Swagger documentation would be useful only in lower environments. Okay, in the production systems, they'll disable the Swagger most of the times. They won't enable it. Okay, Swagger endpoints and its UI for accessing all the input would be useful when you are doing some testing in your lower environment. let's say in dev region or staging region, you want to do some research, you want to do some testing, API testing. Okay, you want to see all this stuff. Okay, actuators also, you will not enable all the actuators in the production, right? Only few endpoints will be enabled, and most of the times Swagger will be disabled in production code, they won't enable it. Okay, it is a kind of little burden, and it will make the application little heavyweight and also not secure, because if somebody is able to access, they'll see all the endpoints using a Swagger docs, right? They'll see all the details. It will give clear picture about each and every endpoint. So due to some security reason, other reason, they'll disable the Swagger in production. They don't use it. Okay, Docker Compose. So Docker Compose, you can use it. My best suggestion is, don't go for most of the people, they don't go for Docker Compose. They'll enable each and every individual component separately. Let's say you want to use Kafka, you want to use Redis database, you want to use some other third-party mechanism. So if you are using a Docker in production, most of the time, they won't prefer to use the Docker because it will fetch the images until and unless the companies have their own Docker repository and they are maintaining their own repository and they are publishing images there. And if their application is very complex, it is composed of lot of components, lot of third-party software, then you need Docker Compose. Otherwise, you don't need to go for that. You can actually configure the individual components. If your application is not very complex, if it is not involved with a lot of components, different components. So Docker Compose is only required when your application is very complex and you want to use multiple softwares. So multiple softwares at a time, it would be difficult. So then Docker Compose, if you have a Docker Compose, you can simply build images and upload the images into registry, and then you can do the stuff. Okay, but your application is a medium sized application and what are the components, and you better configure them and separately. Of course, if you keeping deployment approach in mind and you want to have very less control over the configuration part, you want to have a less control over the configuration, you want to make it as a more of automated, or it's more of a the customer developer, if you think the developer involvement is not required much for deployment process, for other stuff, you can use the Docker Compose. It will automate the stuff. Okay, that is the thing. And some of the things are mentioned here. Load balancing is very important. Content delivery network for caching mechanism, you need to take care of that, and those are the very important thing, right? And you can security, you can actually configure proxy servers. Okay, you can also use reverse proxy if you want, based on a requirement. And what else we missed here? We covered the analytics, data analytics, we covered security, we covered caching mechanism, API gateway, readability token, and authentication authorization part. Okay, these are important. So monitoring details. So you are going to feed when you are building application, monitoring is very important, logging and monitoring. So in the design part, you have to take care of the logging and monitoring. You see, when you are building a application with multiple services, because you are, as per your domain, right, if you are having multiple services, multiple modules, and you want to track all the logs, right, there will be multiple logs, and you want to track the request, how the request is propagating. Let's say if you are taking multiple millions of requests are coming for your application, and you want to track all the request details, right? You want to track the details as per the timestamp also. Then you can actually feed all this data into separate database, MongoDB, okay, any other NoSQL database, and from there you can actually feed this data to monitoring, centralized monitoring tools, and you can actually see that you can use Elastic Search Engine, Kibana, or some other monitoring tools are best monitoring tools are available in market. You can actually use the Splunk is also there, you can use for logging, monitoring, searching purpose. So many third-party monitoring software tools are available in market, you can use them. So logging is very important. You see, logging and observability, I told you this is very important, right? You need to enable distributed tracing, logging. Okay, there are some concepts like trace ID, spawn ID. For each and every log there will be trace ID. For each trace ID there will be multiple spawns, so you can actually spawn. If your request is coming, it will be identified by the trace ID, how the request is propagating through multiple microservices, and the same request wants to perform multiple process, and we will have a spawn ID for each and every process, and each spawn each sub process will be identified with the spawn ID, and we can actually see that. So these things are very important when you are designing a system here. As I explained you, it is simple and straightforward, is not very complex here. We do have a very complex designs, complex architectures are there, but it is very straightforward, very simple design, simple high level design for e-commerce platform. So far we discussed this one. Okay, and you can see text stack. Generally we are using Spring is everywhere. Spring security, database. Production design, people don't use the MySQL because it is open source. They go for Oracle or DB2. You still can use the MySQL with the paid version, but the production grade databases like for relational Oracle or DB2, you can go any other vendor. Caching, you can use the Ready, CHCache, concurrent map. It is up to you. Okay, JWT tokens, you can use it. Documentation, it is up to you. You can generate other document, or you just add a Swagger API and only enable it in lower environments. Okay, and this is how it works. You can also set up the Docker is a good approach, because you can Dockerize your services. Nowadays, we are Dockerizing our services and deploying that into cluster. So you are containerizing your application. Containerization is very important. You take any industry, if you are having something in a container, you can simply ship them to different systems. You can deploy there in your on-premises system. You can also deploy them in cloud, right? So container can be deployed anywhere. The migration would be very useful. They are very flexible to deploy in any kind of environment, right? You can deploy it on on-premises servers, or you can also deploy it in any of the clouds, Azure cloud or Amazon or Google. You can take anything. Okay, So containerization became very popular nowadays because when you containerize particular thing, you can scale the containers very easily. Scaling would be very easy. You can spin up multiple container instances in a fraction of seconds. Okay, you can create and you can destroy the containers. You can migrate the containers, from one virtual environment to another virtual environment. Moving container is very easy, rather than migrating applications that are very native or dependent on particular OS or particular servers. So that is the containerization is very important. So dockerizing things, and once you dockerize them, you can actually play with the containers inside a cluster. You can create a cluster. Inside the cluster, you can spin up multiple number of instances as per your requirement, right? People are using Kubernetes cluster, but you can also set up your own cluster. You don't need to. It is not a mandatory that you should use a Kubernetes cluster. Kubernetes, it is one of the container management cluster, but in the production, most of the time they'll set up their own cluster with the PCs. You can actually deploy if it is a very complex application, and if the clients don't want to use the Kubernetes for deploying these containerized applications, they can actually set up their own clusters using different missions. Using missions, they can set up their own clusters in different regions, right? You can actually deploy it. Kubernetes is having some mechanism like auto healing, notifications. These are just automated stuff. In generally in production, and for most of the application, they'll have their own release management people who can actually monitor and automate the stuff. Site reliability engineers will be there who can actually automate this deployment process, maintaining this infrastructure. They'll automate the stuff. It would be very secure comparing to the Kubernetes cluster, because if Kubernetes cluster, you can use it, but the thing is you are depending on the Kubernetes here. And if you want to create your own custom sized servers and you want to create a very complex cluster, okay, which can be very messy, or which may involve a lot of service meshes, so you can go for the manual approach. Without Kubernetes, you can deploy them and you can manage the things actually. And that is the way, see, most of the production level production level application deployments, a production level architecture will be like that. I can say that way. But nowadays people are preferring the Kubernetes. I don't think every client prefer to use the Kubernetes. Okay, so that's all about it for today. Thank you for listening.